and welcome to the first episode of my new calculus series. So this is my first episode of actual content, so please bear with me. And I may have some construction noises going on in the background, but that can't really be avoided right now, so I'm sorry. Today's episode is going to basically be an introduction to what calculus is and why it's important. And I want to clear this up. There's a common misconception that calculus is extremely hard and like only the smartest people can do it. But that's absolutely not true. It's no harder than any other math concept out there, algebra, whatever. I would just describe it as the leap from arithmetic to algebra is similar to the leap from algebra to calculus, but just like when you learn algebra, eventually it gets easier and then it's just second nature. The same thing happens with calculus, and it's not any more difficult than any other concept out there. So I'm going to be following an AP Calculus textbook, kind of as a guide, Calculus of a Single Variable AP edition. And today I'm going to be going over basically the contents of section 1.1. I don't find this section super important because it doesn't actually have a lot of meat to it. It's just kind of an overview of what the goals of this course are. So we're going to talk about the two main branches of calculus and what the point of each one is. So there's two main parts of calculus. There's the differential calculus, which you've probably heard of. There's things called differential equations. That word has probably been thrown out there sometime in your math career. I don't expect you to know it though. And then the other branch of calculus is known as integral calculus. These two branches are very closely related, but they mainly serve two separate purposes. Differential calculus is about these things called derivatives, which are essentially rates of change. And what are rates of change really? They're just slopes. So differential calculus is all about slopes, and it's about taking a graph, let's draw a random one right here, and being able to pick up any point on that graph and draw something called a tangent line. And what a tangent line is, I just drew one right there, not very well because it's curved, but pretend that it's a line. A tangent line is a line that intersects a function's graph at one point and has the same slope as it at that point. I know my drawing skills are far from perfect, but you get the basic idea. One of the main problems in calculus, differential calculus, is connected to something called the tangent line problem, or the tangent problem. Basically what the tangent problem is being able to find equations or the slopes of these lines at any point on a graph. So I could say, oh, find the tangent line at this point and draw it in or whatever. And you would be able to do it using differential calculus. Now moving on to the integral side of things, you may have seen this in math videos previously, but integral calculus is connected but serves a different purpose. The purpose of integral calculus is mainly to find areas under irregularly shaped curves, such as this one right here. Let's say if you wanted to find this area right here, normally with algebra and other methods, you would have no idea how to do that, except maybe, let me erase this really quick. I'm sorry. We got our curve back. One way that you could estimate this would be to split this thing up into rectangles and then find the areas of those rectangles, because that's a lot easier to find than this misshapen curve would be. You can find areas of those rectangles to estimate the curves And if you fit more and more rectangles in there, squeeze them closer and closer together, thinner and thinner, the closer you are going to get to the actual answer. And this brings me to talking about the next point, is calculus, differential, and integral is all connected by a concept known as a limit, written as LIM. Limits are interesting. I will explain them more in depth in the next video, but limits are all about getting closer and closer to a certain value, but not actually approaching it. For example, we could be talking about integral calculus, and we want to find the limit of the area of this area here, as we get infinitely many rectangles. But you may be asking, how do we find that? You need limits to do that. There's no other way. So the main takeaway from this is that calculus has two main branches, but they're both connected. There's the tangent problem, and I forgot to mention it, but sorry. This over here is known as the area problem. The area and tangent problems are highly interconnected, and of course there's more applications than just these two, but these are the two main problems that form the crux of what calculus is. And once you start getting a firm understanding of limits, you can start getting into these two branches more in depth. I think that's going to be about it for this video, because as I said, section 1.1 isn't that meaty. There's not a whole lot to it. It's mainly just an introduction to what these things are, what's calculus, what's pre-calculus, etc. So I'm going to sign off for today. Thank you for watching. Next time we'll be talking about section 1.2, which is about limits. I'll see you guys then.